Good morning and welcome to the Foundation for a Smoke-Free World webinar, part of the Economics webinars series. I'm Patricia Kovacevic, and I have the pleasure to introduce the distinguished presenters today. I'm an external consultant for the Foundation for a Smoke-Free World. We're very grateful that you're able to participate and looking forward to an interesting discussion after our presenters finish their respective presentations. As always, we have a couple of administrative informations to provide you with. You're welcome to ask questions through the Q&A function of Zoom, which you can find at the bottom of your screen generally. There is also obviously the option to reach out to the presenters after the webinar is over. If you have follow-up questions, I am sure they'll be very happy to take your questions. Also, as it is the case with previous webinars that you may have attended or watched, within a short period of time, the webinar will be available on YouTube. So you will be able to watch free reruns of this webinar. Today's webinar topic is e-cigarettes and smoking, correlation, causation, and selection bias. People who use e-cigarettes often smoke. That doesn't really mean ends don't help smokers quit. Of course, there may be some overlap, and there are different evolution patterns in their use. The main presentation today will be given to us, obviously following a foundation grant, by Professor James Prieger, a professor of economics and public policy at the Pepperdine University School of Public Policy, a PhD graduate in economics from the University of California at Berkeley, focusing in his current research on taxation of tobacco products, illicit markets for tobacco, and also how e-cigarettes relate to such unintended consequences of regulation. Professor Prieger has written extensively for different scholarly journals on a vast array of policy and economics topics, such as the link between law enforcement and violence in illicit markets, the impact of telecommunications regulation and innovation, broadband deployment and the digital divide, cell phone usage and traffic accidents, the impact of the Americans with Disabilities Act on retail firms, and entrepreneurship and economic growth, and the determinants of civil engagement. His research has been published in, among other, Review of Economics and Statistics, Economic Inquiry, Journal of Applied Econometrics, and the Journal of Regulatory Economics. The intro to his presentation, though, just to set the stage, will be done by Professor Donald Kenkel, whom you have seen before in some of the foundation events. Professor Donald Kenkel comes to us from Cornell University as a presenter. He is Joan and Irvin Jacobs Professor with expertise, extensive expertise, I should say, in areas of health economics and public sector economics. Professor Kenkel studies economics of disease prevention and health promotion, conducted a number of studies on the economics of public health policies, including alcohol taxes, as well as other policies that prevent alcohol problems, cigarette taxes and their effect on preventing youth smoking, and advertising to promote smoking cessation. His current research, which is very related to the topic, of course, of this webinar, is on the economics of tobacco regulation and the market for e-cigarettes. Without further ado, I'll let Professor Kenkel set the stage, and then we'll turn to Professor Prieger. Professor Kenkel, thank you.
Thank you. And thank you to the Foundation for a Smoke-Free World for organizing this webinar and getting us together here, and the opportunity to hear James Prieger talk about his really interesting research. I think just very briefly to set the stage, I imagine everybody that's attending at this webinar, is fully cognizant of the public health challenge that smoking continues to pose for the world globally, as well as each individual country that many of us, I imagine a lot of countries represented in the audience here. I mean, globally in 2018, there were 1.1 billion smokers, and an estimated 7.2 million smoking-related deaths each year, or in 2018. So we're talking about, again, 1 billion smokers and nearly 10 million deaths. So this is this massive public health crisis problem that it's easy to sort of forget about, I think, sometimes, frankly, in the public health world, because it's been going on for so long, but it's still there, and it still poses a challenge just across all countries, really. One thing that's really striking, though, is the new potential for tobacco harm reduction. And these are products that are actually reducing the risk of smoking, and essentially by non-combustible forms of tobacco. And as the old saying went, people smoke for the nicotine but die from the tar. And so by not having combustible tobacco products, these newer tobacco products provide nicotine that people are addicted to, but without the tar that's killing them, without the carbon monoxide that's killing them. And while this seems to offer a great potential, as a social scientist and as a policy analyst, I'm really struck by the fact that policy approaches have varied so widely across the world. I mean, we range from places like Sweden, that has a quite established record of encouraging smokers to switch to snus, a form of smokeless tobacco that's non-combusted, and they've had tremendous public health gains from that. The UK more recently has been promoting smokers to use e-cigarettes as a way to quit smoking. Then you have, a range of policies that might allow e-cigarettes to be sold as commercial products, but you also have places like Australia that are now requires them by prescription only, and you have places like India that ban them completely. So we have this, range from, encouraging tobacco harm reduction products to banning them across the world. And I think this offers a really interesting both opportunity for researchers, but also some challenges to be sure that whatever research we're doing contributes to the specific policy. And so, James's study is about South Korea, and that's, an important part of the picture. I'm based in the US, and, we're somewhere in the middle of that range where the e-cigarettes and other harm reduction products are regulated, but not exactly promoted in some extent. I mean, the FDA has taken some very important steps, and I think this really deserves a lot of attention. That the US FDA has now authorized the marketing of a form of snus as a modified risk product, a reduced risk product. It's authorized a heated tobacco product as a reduced exposure product. They're not sure about the evidence that actually reduces risk, but they know it reduces exposure to these harmful constituents. They've authorized nicotine packets, or nicotine discs and lozenges, and they've authorized some brands of e-cigarettes as appropriate for public health. And I think this is showing a very important recognition by the FDA that e-cigarettes and other tobacco harm reduction products I just listed do offer the potential to reduce the risk if smokers can switch to them. And that's again, that's exactly what the FDA said about the cigarettes, for example, that they're appropriate for public health because the benefits to adult smokers who quit outweigh other possible costs, at least for the tobacco flavored e-cigarettes that they've authorized. So in all this, I don't want to understate the controversy about tobacco harm reduction. There are important trade-offs, and it's easy, I think, to get a lot of attention has been paid to the question of exactly how much harm reduction do you get from switching from a combusted product to a non-combusted product. I actually think that's not where the action is really, where we really need the evidence, to make better action for policy. I think it's really the social science questions that matter. How, we know e-cigarettes and other products are a lot less risky. Exactly how less risky is not as important as figuring out, well, how are people going to react to their availability? How many people are going to use them to quit versus how many of them are going to continue to dual use? versus how many of them might continue, or how many new kids might start using them who might not have even used combustibles to begin with. So those are all social science questions. And those are questions that economics can address, because we have a lot of expertise in analyzing data on how people make choices in markets, and that's what's going on in tobacco health products. So that's where I'll leave it and hand it off back to Jim to present his research.
Okay, thank you very much. I'm going to start a PowerPoint now, so bear with me. Okay, so the title, as mentioned, of my talk is E-cigarettes and smoking, looking at correlation, causation, and selection bias. Or less formally, the question is, does the use of e-cigarettes make quitting combustibles less likely? And this is joint work with Anna Choi, who was at Pepperdine when we did some of this work, and now she is at a university in Korea. And I thank the foundation for a grant that supported this work. And in addition to the voluminous amount of words on the screen in the disclaimer, that boils down to I don't speak for them and they don't speak for me. This is independent research. And thank all of you for joining us today. Okay, so I am interested in looking at what the data can say about smoking and cessation, and in particular, the role that e-cigarettes, or ENDS, as I will refer to them from now on, might play in that. Now, of course, it is true. Pretty much any place where you look at this around the world, you will find that use of ENDS and smoking are positively correlated. And this comes out in survey after survey. I'll just refer to these as observational studies. In other words, studies where you just ask people, what are they doing? And it's not a controlled experiment or anything like that. Now, the obvious question that comes to mind, at least for people who are serious about working with data, is that there's probably going to be selection bias here. And the term that economists often use is selection into treatment, where treatment in this context just means using ENDS. And the point is that people are not randomly assigned to use e-cigarettes or not. People are choosing to do so. And therefore, there might be many factors causing them both to smoke and or to use e-cigarettes that we don't observe that might induce this correlation. And so what we do in this study is to try to bring to bear some powerful econometric methods to disentangle these potential selection effects. And so the empirical challenge that we set for ourselves is, what if the only thing we had available to us were these same observational studies, these same cross-sectional survey results that some of the critics are pointing to say that ENDS use and smoking, since they're correlated, there must be some causation there. What if we used similar types of data, but applied more advanced methods designed to actually discern what's really causing what? And this is in the backdrop of course, we have better data sets that have been analyzed out there. For example, there are now well over a dozen or even a couple dozen studies that have been covered in a wonderful Cochrane review within the past year, showing that ENDS use can support cessation, and these are randomized controlled trials. But nevertheless, the further you get away from academia and the closer you get to public health professionals and regulatory officials in certain parts of the world, the more they'll just point to the fact, well, there's a lot of dual use. Therefore, e-cigarettes, for example, must be a gateway to smoking or must help people continue smoking when they want to quit. And so the nub of our research, the main result is just we show that even with cross-sectional observational data, there can be a discernible positive causal impact of ENDS use on cessation. And again, our data will be from South Korea in particular. And so let me say a little bit to set the stage for what's going on in that country regarding tobacco control and smoking. So the smoking rate in Korea is still relatively high compared to many other parts of the world. It's much lower than it used to be, as you will see in a moment. So as of 2018, the last year of data that we analyzed, smoking was down around 35% for men It's much lower, at least in the official statistics for women, and so we focus on men in this study. And the usual elements of tobacco control, taxation, advertising campaigns, public health campaigns, and so forth, have worked well historically in Korea. This smoking rate is less than half of what it used to be. And so the question is, could use of ends and further encourage switching away from smoking for those remaining pockets of smokers and those new, smaller but new cohorts that still take up the habit of smoking? And the other important thing to know about the regulatory and cultural setting for e-cigarettes is that all of the official announcements and pronouncements from the governments and the health ministry have been very negative towards e-cigarettes. And in particular, there was a well-publicized announcement in 2015 that will play a role later in our empirical work that was extremely negative. It was from the health ministry, and they said, rough but accurate as my co-author assures me translation, that not only should e-cigarettes not be used for cessation, they cannot be used for cessation. So here's what we do in our study, and these are the points that I will walk through in the rest of this talk. So first, I'll present some statistics on smoking time series and the current situation in Korea, and also on the use of e-cigarettes. I will demonstrate to replicate the common finding elsewhere that the two are positively correlated, smoking and ends use. Then I'll conceptualize for you, before we jump into anything empirical, of what might be going on with selection bias. I'll present some first indirect evidence that selection bias got even worse after the government's negative announcement in 2015. And then I'll turn to direct econometric evidence to measure the extent of the selection bias and to determine what the causal impact of ends use might actually be on cessation. And I'll do that with a host of models that I will talk a little bit about later. So first, let's turn to the situation in Korea. Now, the data that we use come from large-scale public health surveys, and the main one that we will use for the e-cigarette era is the KN Haynes data set. And there is something that might affect what you see in the data. So the survey question asked about e-cigarettes and used that term only up until 2018, the last year of the data. And then it also asked separately, and we fold into our definition of ends, a question about heated tobacco products. So if we, and these were introduced before that survey year in the country. So in 2017, for example, if some guy was using heated tobacco in Seoul, and he was asked a question, do you use e-cigarettes? Well, we don't know. Would he have said yes or would he have said no? It depends on whether he thought that product included. And we can't really do anything about that in the data. So here's a longer time series looking at how smoking was very, very prevalent among men in 1980. Just take that as a starting point here, and has dropped a lot. So we're starting up around 80%, and by the end here, we're down below 40%. And as I mentioned, that's down to 35% by 2018. This just blows up the last few years of the data to see what's going on a little more closely. And again, you can still see the overall downward trend in recent years, but you also see some reversals. So for example, there was a large tax increase in 2014, 2015 that brought down the smoking rate by relatively large amount by what had been happening in the years before that. But then you also see this rebound effect the year after. And so this just raises some concerns that maybe there's some diminishing returns that we're hitting here with the standard tobacco control sorts of things that we would do. So let's take a look at e-cigarettes. Now, first of all, just notice that overall, pay attention to the scale of the graph over there on the left side. These are small numbers of people, relatively speaking. And again, these are for men. And so we're seeing, no more than 5% of people are using these products, at least during these years. Now you see a large uptick in 2018. We suspect that at least some of that, if not all of that, is due to the specific question about heated tobacco now being asked in that first year. Notice a large drop, particularly large in percentage terms, dropping from 4% down to about 2%. 2015, 2016. This is after that negative report from the government that again said that e-cigarettes should not and cannot be used for cessation. Okay, so who is using them and why in Korea? So here are 2 years of data. This is before and after that negative announcement. The darker bars are for 2015. Notice that most people are using them, whether they end up working or not, at least because they say they want to quit smoking. And that's that bottom category there. Another large chunk of users use them because they think that they're less harmful and that they don't have the unpleasant odor of cigarettes. A lot of people are just curious too. Curiosity is a large category there. And then the ability to smoke indoors. Well, notice, first of all, that's a horrible way to word that question. This is not smoking. Nothing is being combusted. And also, it wasn't necessarily legal to use them indoors anyway. So that's a much smaller category there. Here's what I want to point out, though. So we have this negative government report that comes out. And look how many people did not use the next year and to try to help them stop smoking. So we lost about 300,000 people who were no longer going to try to quit smoking by using e-cigarettes. Very large impact. So who is using these, dual use and so forth? Well, first of all, very few people use e-cigarettes without having smoked in the past. Okay, so 85% of current e-cigarette users are also current smokers, so that's the dual use, and then 12% are former smokers, and only 3% say that they never smoked at all. Okay, on to the second main point, which is to demonstrate, as other studies have shown, the positive correlation, if you don't control for anything and just look at correlation between smoking and use of e-cigarettes. So our data, as I mentioned, are from the KN Haynes. You might not be familiar with this particular data set, but if you're familiar with the United States version of the NHANES, the National Health and Nutrition Survey, the Korean version was modeled on that same survey, so very similar. Data that asked about e-cigarettes starts in 2013, and we finished the study up at a time when 2018 was the latest data that we had available to us. So we have many tens of thousands of observations. These are repeated cross-sections. Importantly, this is not longitudinal data, so we're not able to follow individual smokers or e-cigarette users over time. The usual things, it's from a survey with complex survey design, so of course we had to account for that appropriately when we conduct inference, and we did so. Oh, also I should mention, we are only looking at what we'll just call adult smokers, smokers of legal age in this study. Okay, so the first thing that you would do, and there are studies in some public health journals inside and outside of Korea that have literally done nothing more than this, which is just where you regress whether someone smokes on a bunch of demographics and then whether they use or have ever used e-cigarettes. And so we start with that, what we call the naive regression approach. And we get very large apparent impacts. And this is true whether you control for other demographic observable factors or not. So I'm showing here a regression where the sample consists of males who ever smoked, so past smokers and current smokers, controlling for many other demographic factors, just about everything we could observe in the data. And then these are regression coefficients here that you can read, just multiply them by 100, and this would be percentage points apparent association between, for example, currently using e-cigarettes, it looks like that makes you about 25 percentage points more likely to be a current smoker. Or if you used e-cigarettes in the past, it looks like that makes you have 33 percentage points more likely that you are a current smoker. Okay, so we see these large positive correlation, and of course the question is whether there's anything causal there. So why might there be selection bias, and what do economists mean when we talk about selection bias? So first, just pictorially to get into this issue. For simplicity, our modeling does not depend on this breakdown, but just for simplicity, assume that there are just two types of people out there. A type 1 individual is someone who, due to genetic factors or whatever, cultural factors, is more likely to smoke or potentially has a higher potential for addiction once experimenting with cigarettes, or has a lower desire to quit. Okay, so just there's something inherent in this person with these characteristics. And so just starting at the bottom left of this diagram, we'll just assume that there's a bunch of these individual factors that the statistician cannot observe in any empirical work. Now over on the right, think about the two behaviors of ends use and smoking. Well, because of these unobserved factors that might cause both use of e-cigarettes and use of cigarettes, there will be therefore positive, strong correlation observed in the data, that's the orange arrow here, between these two events, even if, as hypothesized just for purposes of this diagram with the dotted arrow, that there's no causal effect. Okay, so even if ends use has no causal impact at all on smoking or continuing to smoke, these unobserved individual factors or confounding factors, as a statistician might say, could induce positive correlation in the data, and that might be what we observe. Now for a type 2 individual, this individual this might be kind of on the other end of this imaginary spectrum, less likely to smoke, less likely to get addicted, higher desire to quit if it does start, again, due to some unobservable factors to the statistician. And in this case, if, for example, there is a negative causal effect of ends use on smoking, then the overall correlation that you might observe is probably going to be weaker. It might be positive or negative, but again, there's competing effects here. The true causal effect versus just spurious correlation, as we would say. So what we want to try to do in our modeling is use models to get at that causal arrow, not just the correlational arrow. So to first provide some evidence for selection bias before doing much with any fancy econometric techniques, we rely on a notion in the health econometrics literature, if you can call it that, that says that when there's some sort of announcement or report or some publicized fact about some new product or a vitamin, or in this case, e-cigarettes, related to the health effects of that activity or product, if we see changes in the observed characteristics of consumers using that product or doing that activity, then that might also be a signal that there are changes in the unobserved confounding factors as well. And so the announcement that we have in mind here, of course, is this 2015 pronouncement. The health ministry, they said that e-cigarettes were dangerous to health. The way they worded the announcement doesn't quite say this, but the casual reader could be forgiven for assuming that they were saying that e-cigarettes are just as harmful as cigarettes. And so what we do first is look at, okay, so who's among people who are using e-cigarettes, who used them before and who is now using them after this announcement? And we see a very interesting shift in the observable characteristics. So comparing the 2 years surrounding that announcement, after the announcement, the people using e-cigarettes are older individuals, people with lower income, people with less education, people more likely to report binge drinking in this health survey, and people with worse self-reported health. And from elsewhere in the literature, we know that each one of these factors is associated with less probability of cessation. And so what we are seeing here is a movement perhaps away from type 2 people using e-cigarettes and more towards type 1 people. And this also comes out if we repeat the naive regression. We see that this apparent association between ENDS use and smoking increases a lot, which is further evidence that something is changing with these unobserved confounding factors. So what I want to do now with the roughly 10 minutes that I have left is just to walk through a little bit of what we do with the econometrics. Now, I want to be sensitive to the fact that some of you might be practicing applied econometricians, others of you, and most of you, in fact, probably are not. And so I won't try to get too lost in the technical details here. So what we do is we turn to a literature intended to estimate causal endogenous treatment effects. And these are designed for cross-sectional non-experimental data. In other words, the exact sort of data that we have here and the exact sort of data that some public health officials point to argue that dual use implies that e-cigarettes are bad for cessation. Now, you will see the word treatment being used in these models, and that is because, so what's being treated here? Well, nothing in the clinical sense, if you are an MD, for example, but this literature takes the language from randomized controlled trials. And so the treatment here is just econometric jargon for the activity, in this case, use of e-cigarettes, ENDS, that will be under study. So what do we have? How are we going to try to get some direct evidence for selection bias? So as I mentioned, these are endogenous treatment effects models. Now that word endogenous there, another buzzword from econometrics, just means that this is not randomly assigned treatment. People have selected into treatment. People choose to use e-cigarettes or to not use them. And we have to use the twist on these models where both ENDS use and smoking are binary variables, binary outcomes measured with 0, 1 type variables. So there are two equations in these models. The first equation is just trying to assess what's going on with the use of e-cigarettes. So if you are familiar, for example, with a probit or a logit regression, this is the basic form for this equation. And same for the second equation. The second equation is the binary outcome is current smoking, yes, no. And sorry, it's no, in these models now it's going to be cessation from smoking within the past 8 years, that time period chosen to roughly coincide so that in the first years of our surveys, that's about when e-cigarettes were introduced and becoming popular in the country. Now, you might just wonder, well, why don't you just use data on whether they started using e-cigarettes first or whether they smoked first and so forth? The survey questions were not worded in such a manner that we know that. So we know nothing about temporal precedence. And this is what is called a triangular system of equations, which just means that the dependent variable in the first equation for e-cigarette usage shows up in the second equation for cessation. And so briefly, here is the more formal presentation of the model. We have a treatment equation for e-cigarette usage. And so that will just be modeled again, like a probit regression as a function of observed characteristics, those are the Z's, and unobserved determinants, that's the U sub I. And the second equation for cessation in the past 8 years, and is also a binary dependent variable. It's modeled on some observable characteristics, those are the X's. Unobservable characteristics, that's the epsilon. And importantly, this is the triangular part of the system, you see that D, the dependent variable in the first equation, shows up as a determinant of cessation. And so the coefficient tau is really what we're trying to estimate. Tau is the causal effect of smoking. Now, importantly, these models assume that there is correlation in the confounding factors. And this is where the endogenous, the endogeneity and the selection bias enter in through the technical means. So that's a quick walkthrough in the model. Now, how do we estimate it? Well, since we're going to have to rely on some assumptions about functional forms of various things, we didn't want to just estimate one model and call it a day. And so we estimate a host of models here. So first of all, we estimate a simple bivariate probit with and without correlation between the error terms. So if we don't allow any correlation between the error terms, then we are essentially just back to the naive regression. So that is used only as a baseline. And then we use some other modeling techniques just to vary the assumptions to make sure that our results don't depend on any one set of assumptions. And for the sake of time, I'll just very quickly run through these. Copula models are a technique that have gained prominence in the literature in the last couple decades. And then one slightly less parametric model, Jeff Wooldridge's control function model. And then we have various versions of these models as well. Okay, so now in the third bullet point, this is important. So what is the treatment effect that we are estimating? So we are estimating what is called the average treatment effect on the treated. In other words, among individuals who choose to use ends, what is the causal impact on cessation for them? And since we have many models to be estimated here, we use formal model selection criteria to choose among them. Very briefly, let's just take a look at some of the numerical results, and we can focus on the first column, the average treatment effect on the treated. Now, notice first that the naive regression, the top row, replicates the results from our naive regressions earlier in the talk. In other words, this negative 0.147 means that when you don't control for the possibility of selection bias, it looks like the causal effect of using e-cigarettes is that you're 15 percentage points less likely to have quit smoking. But notice that that negative sign in that first column top row turns positive is in all the other models, which is to say, as soon as you control for selection bias, the causal effect completely switches around. And so now by, for example, the bottom row, which is the one that is preferred by the model selection criterion, now we are seeing that there is apparently a 16 percentage point causal effect that using e-cigarettes will help you quit smoking. And there are some other versions of the model. I won't dwell on this slide. But again, the preferred models are the ones at the bottom, and that 16 percentage point, give or take, let's just say plus or minus 1, appears to be a relatively robust result among the preferred models, which is nice because each of these models relies on slightly different assumptions, and so the results apparently do not. So let me finish by talking a little bit about some of the strengths and the weaknesses of this modeling, and then I'll wrap up. So I would just say that unlike much of the public health research, now not all, of course, there is a full range of statistical sophistication in the public health literature as elsewhere. But I will say that unlike much of the research we ran across, particularly addressing this question using data from Korea, that a strength of this work is that the possibility, and to an econometrician, I have to say the near certainty that there are unobserved confounding factors is built explicitly into the model. And so we can address that directly. Now, I will say as a weakness that the identification of these causal effects, of course, is not going to be as convincing as if we had a randomized controlled trial, or even if we had longitudinal data where we could follow individuals over time. And that is because we only have cross-sectional data, we are unavoidably forced into making certain parametric assumptions. And again, that's why we estimated many different types of models so that we could vary those assumptions. So I guess I would just say we don't see this research as the final answer on this question. But I think the strongest contribution here is even if we take on the naysayers on their so-called home turf of just looking at observational data and dual use, this work shows that at least with the Korean data that we analyze, that we can show that selection bias drives their pessimistic conclusions, and we actually find the causal effect goes in the other direction. Okay, so just 5 points to summarize here. I would say that our work suggests that the smokers least likely to quit are the ones using e-cigarettes, and that's causing the apparent correlation between the two practices. But that correlation is not from a causal factor necessarily. In fact, point number 2, it appears that these unobserved confounding factors really appear to be driving that correlation. Once we correct for that, point 3, then our estimated causal effect is between 16 and 17 percentage points in the direction of use of e-cigarettes helping promote cessation. Combining facts 1 and 2 and 3 leads to point 4, that there is apparently very severe selection bias in these naive observational analyses. And so the result of all this is point 5. These two statements do not contradict each other. Smoking and ends using ends are positively correlated, but ends can have a positive causal effect on cessation. So that's all I have here. We'll pause now for some more comments from Dawn and some questions, I believe. Thank you very much.
Thank you, Professor Prieger, for the fascinating evidence. And I don't know about the rest of you, but for sure, I will be very tempted to go back and reread some of the statistics courses I took in the past, because certainly the terminology is very fascinating. Turning it over for a few minutes of comments to Professor Kenkel. But before I do that, let me remind you to place your questions in the Q&A box, because of course you're all on mute. And we'll be very happy to address, or I'll be very happy to read your questions to the presenters. And also, let me take this opportunity to remind you to visit the Foundation's website, www.smokefreeworld.org, for navigate through it, and you'll see a variety of research papers, reports, working papers published, everything that eventually is materialized in the research form eventually will be published on the website. So take this opportunity after the webinar to visit again the Foundation's website and see what's out there. Professor Kenkel.
So I really enjoyed both learning about this research and also Jim's presentation of it this morning, or whenever it is, wherever you are. I always like to begin with some general overview comments. I mean, I made some of these at the introduction to the entire talk, but I will point out, the prevalence of smoking, as Jim pointed out, is still 35% of men in South Korea are smoking. And these harm reduction products do offer this potential to reduce this. So what this paper provides is new evidence that e-cigarette use helps South Koreans to quit. And I'd say, what it contributes is the sophisticated econometric analysis of observational data from this Korean NHANES data from 2013 to 2018. And that, just to recap those numbers you just saw, the best estimates seem to suggest that e-cigarette use increases smoking cessation by 16 to 17 percentage points. And I guess that's over 8 years. That's a detail that had kind of slipped by me earlier. I want to take a step back and mention a little bit deeper something that Jim had also mentioned, is that there is a lot of evidence out there that from randomized clinical trials that e-cigarettes help smokers quit. One of the most important ones, I think, is the paper by Hajek et al. In the New England Journal of Medicine that was published a couple years ago, where there were 886 UK adults who were trying to stop smoking, and they were randomly assigned to either take a nicotine replacement product of their choice, or they were given an e-cigarette starter pack with a recommendation to purchase more e-liquid as they went along. And after following them up for 1 year, among the nicotine replacement group, the 1-year abstinence rate was 9.9 percentage points, while the e-cigarette group was almost double that. It was 18 percentage points of the e-cigarette group were abstaining from smoking after 1 year of having been randomly assigned. Now, it's not exact, this was not another arm of the trial, but there have been other studies that have looked at the effectiveness of nicotine replacement versus no treatment. And in those studies, you generally get that nicotine replacement is about twice as effective as quitting cold turkey. So if you sort of put that in there as well, that if people didn't use any product to help quit smoking, their smoking cessation rate might be about 5 percentage points. Note that this would then, from the clinical trial, suggest that maybe a 13 percentage point improvement in quitting rates between trying to go it on your own versus trying to use e-cigarettes. And I think that's quite, in the range, if not actually larger than anything Jim finds, now that I realize that what Jim's 16 percentage point increase is actually over 8 years. So it's a smaller annual change. This is, as I said, sort of, I think, one of the most important studies. It's a very well done study, but the Cochrane review identifies a number of other randomized controlled trials that have looked at e-cigarettes compared to various things, and they conclude that there's moderate certainty, and they basically say it's limited by the imprecision from these studies, that nicotine e-cigarettes increase quit rates compared to nicotine replacement therapy, that non-nicotine e-cigarettes, nicotine e-cigarettes compared to non-nicotine e-cigarettes work better, or that the e-cigarettes compared to behavioral support only, or a peer control group work better. So there's generally good evidence coming from all these RCTs, but there is again limited by imprecision. In this context, I think a natural question, especially maybe for non-economists, is well, why conduct econometric analysis of observational data, not just keep on running more clinical trials? I mean, RCTs are viewed as the gold standard for identifying causality. They have very strong internal validity. The only difference between the people in the control group and the people in the experimental group by randomization is that original randomization. So that gets rid of all these potential confounders, these observables that unobservables that came up in James's presentation. One common concern, though, about RCTs is that while they have very strong internal validity of identifying a causal effect, in this experiment, this happened, it's much less clear if they have external validity to extrapolate out to the real world. And a general claim, I think, in a lot of RCTs is that the efficacy in the ideal conditions of the RCT, and I reversed my inequality sign there in my slide. I meant to say it should have been greater than the effectiveness in everyday practice. That generally speaking, people are concerned that, well, when people are really doing this experiment and they're maybe partly because they volunteered for the experiment, they're being monitored by the experiment, that's going to make the experiment actually work well. And when all those things don't happen in the real world, the real world effectiveness is less than efficacy in the trial. It's also, just as almost unavoidable that, well, the first part's possibly avoidable, but most of these RCTs are limited to subjects who are interested in quitting. And it is unavoidable that RCTs always involve people who volunteered to participate in RCTs, and we're never quite sure how representative they are of the rest of us. On the other hand, e-cigarettes actually might be more effective in everyday practice than in the RCTs, because the smokers who use them can really tailor their use to what works best for them. And they can choose the method, whether they're using e-cigarettes or cold turkey or a patch or whatever. They can choose the product they like the best. They can choose the nicotine level that works best for them. They can choose the flavor that works best for them. And for all these reasons, we might actually think that the e-cigarettes at least could potentially be more effective in everyday practice than the RCT. So that's one good reason to study them. Another interesting difference between the real world and RCTs is that people might pick up those e-cigarettes for a variety of reasons. In the Korean survey, it was mentioned some are just curious. People start using them out of curiosity or for other reasons, might eventually become interested in using them to quit and might change to quit. And there's some evidence from the US PATH survey that people who are not interested in quitting at baseline end up using e-cigarettes and quitting in later waves of the survey. This is limited due to small sample sizes, so I wouldn't make too much of that, but I think it's an intriguing possibility. So I think there's a good reason to conduct econometric analysis of observational data, and not just as, another argument could just be it's cheaper and easier, maybe not easier, but cheaper than running an RCT. But not just for that reason, but because we can actually learn more about it. But as came out in the presentation, the problem here is self-selection. People are not randomly assigned in the real world. There's evidence that there may have been a shift towards more use by cessation unlikely smokers. So they use a nice, many versions of this endogenous treatment effect model of binary outcome. I'll mention a couple of other approaches that other economists have used. A really general set of approaches are these quasi-experimental research designs, difference in difference, instrumental variables, regression discontinuities. And the idea here, as suggested by the term, is that while people aren't really randomly assigned, we can find some situations where it's almost as if they were randomly assigned to get the treatment. And that can be a very powerful way to study these things. And I should point out maybe at this point that, the whole idea of these self-selection models that Jim starts, these quasi-experimental models that I'm mentioning here, those have been at least 2 Nobel Prize winners in economics have run their Nobel Prizes for this work. Jim Heckman on his self-selection model, and more recently Angrist and Prieger and Imbens on their quasi-experimental ones. There's also just the pure estimation of demand functions with own and cross price effects, which is sort of a more traditional approach. One quick slide, and I think this is the last slide, with a few technical comments. I'm always intrigued when I see these things, is the identification by functional form or through exclusion restrictions, or is there an instrumental variable or a quasi-experiment going on in the data in addition to the fancy econometrics going on in the data? If so, that I'd really play that up. My colleague actually pointed out to me a really nice paper that came out recently in the Journal of Econometrics that discusses these models, these triangular recursive bivariate probit models. And I think covers a lot of the same ground, but in a more general and more theoretical way that was covered in the presentation. As I mentioned in the last slide, another approach is simply to look at these reduced form cigarette and e-cigarette demand functions as functions of the own and cross prices. And with that, you can calculate the diversion ratio, which is something they use in IO and antitrust lit to study the change in the quantity of one good caused by the change in the quantity of another good. I think that's another promising approach, that all these would be complementary approaches. So I'll stop here with sort of saying, I think we have at least 4 or 5 complementary approaches to trying to figure out what's going on here. We have the classic RCTs, we have longitudinal data, which neither of us talked too much about. We have the sophisticated econometric methods that Jim Prieger and his co-author used, and we also have possibilities to do things like just estimate demand functions and look at the effects of prices on demand. And any of these things and all of these things can shed light on the question we have in front of us is, do e-cigarettes help smokers to quit?
Thank you, Professor Kenkel. And we already had an exchange in our chat, as well as a question for you, Professor Prieger. So the exchange, obviously, that you've already kindly answered in the chat box was regarding whether similar studies and comparisons were run in other countries. And I know you answered that, in fact, you've focused only on Korea. The question we received was quite interesting. If you're familiar with the so-called EVALI crisis, which is basically a government communication regarding some health incidents following use of what eventually turned out to be tainted cannabis vaping products as opposed to e-cigarettes containing nicotine. So the question was whether there was any awareness or whether the US EVALI crisis government communication triggered into the Korean media, and whether that had any kind of impact whatsoever, if you're aware of that.
Yeah, that's a great question. And unfortunately, it's one probably that my co-author who now lives in Korea knows better than I do. So our data unfortunately end before that episode. That would have been another nice kind of negative shock to the health information regarding e-cigarettes that we could have exploited in the empirical work. So the short answer is I don't know, but I'll follow that up quickly with saying, given the Ministry of Health attitudes from earlier years, I strongly suspect that there were some messages along the lines of, see, we told you they were dangerous.
Thank you. Thank you. We do have another question, which I think it's more addressed really to foundation staff. So probably we won't answer it. I think the other question is whether these findings are shared by the foundation with policymakers. All I can say is, of course, all of the foundation research or foundation founded research eventually is published in, whether it's on the foundation website or publicized through webinars such as this one, which are publicly available. They're not necessarily targeting, a particular audience, but they're, again, publicly available for anybody to see. I do have a question myself very quickly for the couple of minutes that we still have. Have you taken into consideration, and maybe it was addressed and I didn't pay attention to it, the whether in some countries, of course, government messages are more credible than in others. I presume that in Korea, the government messaging is generally considered very credible.
So I would say yes, coupled with the fact, and I will tread lightly to avoid stereotypes, but from discussions with my co-authors, I think it's also a society, at least traditionally, maybe not as much with the younger people, but at least compared to Americans, they would be more likely to respect the message from, credibility is probably a good word for it. I think it was relatively high. And certainly that announcement was very highly publicized in the press. And there was, among the mainstream press, there was never any pushback. It was just accepted and reported as if this were, gospel truth.
Thank you. We do have one last question in the very last minute of this webinar regarding the regression model which was used. It says the question says it's a pooled regression to merge the time and region together with a dependent variable. So how can we use this pooled and cross-sectional data into binary regression or logit model?
So very briefly, yes, the data are pooled, but we also have region fixed effects and year fixed effects to wipe out any confounding factors from differences among the years and trends that's going on, and then also any differences in the regions. So your question, so how can we use in this binary regression model, after pooling and putting in all the fixed effects and demographics, you run it exactly as if it were just cross-sectional data.
I raised my hand to make a real quick comment that
yes, please.
In one of the, I think in the chat, or somebody mentioned the fact that the e-cigarette products have been changing over time and various changes over time. I mean, so while Jim's model controls for the year effects, he could further interact the year effects with the treatment effect to see if the treatment effect varies over time, which it might if the newer products are better, for example.
That is true. Yeah, that's a good idea.
Thank you. Appreciate it. Well, I wish to take this opportunity to thank again our distinguished presenters for taking the time to conduct the research and of course to share the results with us. Thanking all the participants in various time zones, some of you of course very early morning, including Professor Prieger, for joining us. We are inviting you to stay tuned for future economics webinars that will be announced in the future, and of course, as I mentioned, visiting the foundation website as well as was obviously disseminating the replays of this webinar. Thanking again the organizers, the Foundation for a Smoke-Free World, and wishing you all a very wonderful day. Thank you.